So welcome you all for Tungola online classes. We are discussing the chapter ray optics. So in that ray optics, yesterday we started the reflection. So we have seen reflection, loss of reflection, then we have seen the spherical mirror, types of spherical mirror, sign convention rules for the spherical mirror. So after the sign convention rules for the spherical mirror, then so what some terminology related with the spherical mirror, and last we have seen one derivation, that is focal length of a spherical mirror. Okay, so last topic of this reflection today we will discuss is, so that is mirror's equation. Mirror equation or mirror's equation. What is mirror's equation, or otherwise derive, so derive 1 by V plus 1 by U is equal to 1 by F. What is the equation I have written? This equation name is called as mirror's equation. So this is the equation, so very important derivation for 3 marks in this reflection. If it is there in syllabus, if they are not eliminated means, so this is very important derivation, mirror equation. So for deriving this equation, you can tell the name mirror equation. It is only simply mirror equation, or you can also call or derive the relation between. So here U is the object distance, V is the image distance, and F is the focal length. For a mirror, for a convex, for a spherical mirror, either let it be a convex or concave, the relation between object distance U, image distance V, and focal length F is given by a equation. That equation name is called as mirror equation. Okay, for deriving this derivation, so I will consider, you can consider either a concave spherical mirror or convex spherical mirror. Both methods are there, so you can follow any one. So I am considering here concave spherical mirror. This is the pole. That here it is there of center of curvature. Pole is there, and here it is of center of curvature is there. Diagram is very important. First let us listen, then later you can draw. So here somewhere the center of curvature is there, and here somewhere the principal focus is there, and I kept the object beyond the principal focus. So let me consider the object is extended object. Objects are two types are there. One is of real object, other is of point object and extended object. The size of the object, point size, that is a point object. If it is extended object, so this is extended object. Okay, Nara? Now I want to get the image of this object by this mirror, spherical concave mirror. In order to get the image, so here these points are important. So when you will get the image, when the light rays from the object should incident on the mirror. After reflection, the reflected light rays either converge or appear to be diverge. What is the meaning of image? Image is the point at which the light rays after reflection converge. Reflected rays will converge. So the point at which the reflected rays converge or appear to be diverge. Appear to diverge. So this point name is called as image. When the light rays, I will show you with the diagram, I will show you. If the light rays after reflection converge, they will give you a real image. A real image. If they appear to be diverge, they will give you a virtual image. So image of an object may be a real or may be a virtual. In order to get the real image, the light rays after reflection, they should converge at a point. In order to get the virtual image, the light rays after reflection, they appear to be diverge. So this is the main difference between, so which one? Main difference between the real image and the virtual image. Now a concave mirror will always form the real image of the object. Let us see whether we will get a real image or not. But the first condition is to get the image from the object, the light ray should incident on the mirror. So from the object, it is an extended object, many light rays, infinite number of light rays incident on the mirror. But if we consider all the light rays, so our consideration, so derivation will become complicated. Instead of considering all the number of light rays, let me consider only 3 rays. I will consider this is the first ray. So this light ray was incident, so parallel to principal axis. Yesterday you know that whenever a light ray incident parallel to principal axis, after reflection the light ray will passing through principal focus. This is the first light ray now. So ray 1. Can I call this one name is ray 1. This is first incident ray I1. So incident ray I1. Okay na? This is first ray considered. And one more is, so whenever a light ray which is passing through center of curvature, the center of curvature of the spherical mirror, so what happened? This is incident ray, the second incident ray. The center of curvature will like yesterday we have seen. If I want to draw normal to the spherical surface, now this is my spherical surface or spherical mirror. This is my center of curvature. And here the light ray was incident M. The normal round to the spherical mirror is the straight line joining the center of curvature and the point. So center of curvature, the line drawn from the center of curvature to a point will give you a normal. So yesterday we have seen for normal incidence, whenever a light ray incident along the normal, the light ray reflected along the same path. It retraces the path. That you know that now. So that's why whenever a light ray, so incident along the center of curvature, reflected or retraces the same path. So this is the second reflected ray, ray 2. Okay, Nara? And one more light ray, here I am considering this light ray was incident exactly at the pole. So this is the incident ray 3. So what happened? If it is incident at some angle, this light ray will be reflected, so with the same angle. This is my third reflected ray. So you should be careful regarding the diagram. So this is the third reflected ray. I will draw the diagram. So this is my third reflected ray. Okay, na? So can I call this as reflected ray third one. In this incident rays are not required for us. So I required only the reflected ray. First reflected ray, second reflected ray, third reflected ray. So these 3 rays are converging or appear to be diverging. They converging. So that's why here I will get a real image. So actually these rays are coming from A. So it will become A dash and it is B dash. So what is the object here? AB is the object. What is the image? A dash, B dash. So will I get the real image or virtual image? Real inverted image. Image is inverted. Here arrow is above, here arrow is below. So a concave mirror will form a real and inverted image of the object. Clear? And here I place object. So beyond the center of curvature, I got the image. In between where and where? So in between the center of curvature, so I got the image at where? So here which one is the principal focus? So this is the principal focus. Okay, Nana? So here this is the formation of image and this is the ray diagram which is required for which one? For deriving this mirror equation. Okay? If this ray diagram drawn properly, 50% of the derivation is completed. If the question given for 3 marks, then the derivation part up to the diagram you will get 1 mark. But remember, if you not put the arrow marks, in ray optics always remember, without arrow mark the diagram is not considered. If you not put the ray diagram, ray, so symbols, so your diagram is not at all considered. Always keep. Though you have drawn the diagram perfectly, but you forgot to put the arrow marks, then how they will come to know which is incident ray and which is reflected ray. Okay, Rana? Then now you check it. So I will consider the triangle. Here can I call this name is M and this is P is there now. The pole of the spherical mirror is P. Now I will apply the properties of the similar triangles. So which are the triangles I will consider is, first I will consider ABP. From the triangle directly I will go. So first you can write. Now 1 mark diagram over. Actually theory part you can write here. Consider a spherical mirror. of radius of curvature r, focal length f, pole p. Consider one extended object AB placed beyond the center of curvature. Then I got image A dash B dash which is real and inverted. Clear? So okay, now you see from the triangles, so APM and A dash APB or ABP, not ABVP, ABP and A dash B dash P. So you can see the triangle ABP, one triangle, and one more A dash B dash P. So for these two triangle, one vertices is common. So these both are the right angle similar triangles. From the similar triangle properties, you know what is similar triangle property? The ratio of the opposite side by adjacent sides will be same. So from these two triangles, what is the ratio of opposite sides or adjacent sides? Can I write B dash A dash divided by which one? B dash A dash divided by, so B into A na. So what is the opposite side value will be given by what? So will be B dash A dash, which is the triangle here I consider. So I consider the triangle ABP and A dash B dash and P value. So from this B dash A dash divided by B into A, this is the ratio of opposite sides, the ratio of which sides? Opposite sides by, so what is the ratio of adjacent sides are given by B dash P divided by BP. Can I call it as equation 1? So triangle ABP and A dash B dash P are right angled, so right angled similar triangles. From this right angled similar triangles, so I have written this property. Clear, Dara? So after completion of this, next one more triangle I am considering. So the triangle name is given by, so one more triangle, which one I will go through, ABF and so from the similar triangles, from the here only I will write similar triangles. So which one here I will write? So CPM. So what is a similar triangle here I will consider? One similar triangle is MPF. So MPF and A dash B dash F. See this? So MPF, A dash B dash F. One vertices is common, so one right angle is there. So these are also right angle similar triangles. Here though it is not right angle, so we can consider one straight line perpendicular here 90 degrees. So from this right angle similar triangle, what is the ratio of, so B dash A dash divided by opposite side. In this triangle B dash A dash, in this triangle MP will be equal to adjacent side for this triangle B dash F divided by, so adjacent side for this triangle given by, so FP. But here MP value is exactly equal to AB. So that's why, so B dash A dash by A or BA or AB. So is equal to, can I write the B dash F value, B dash F, B dash P minus FP? Can I write? So B dash F can be written as B dash P minus FP divided by FP. So can I call it as equation 2? So this is equation 2. Okay, is it understood? So these two equations I have written by using similar triangle properties. The ratio of opposite sides by adjacent sides will be constant. So now I got two equations from equation 1 and 2. So from equations 1 and 2, what can I write? So can I continue the remaining part here? So what can I write? LHS is equal. When LHS is equal, RHS also equal. So what I will get? B dash P divided by BP will be equal to, so B dash P minus FP divided by, so which one? FP. Are you getting Ara? Now with the sign convention, so substitute the values. What is B dash P? Actually A dash B dash is the image. What is the distance of the image from the pole? Can I write the B dash P with the sign convention? B dash P value is minus V. Why minus V? So distances should measured from the pole. So P to B dash. Though I written B dash P, you have to start from the P B dash value. P B dash value is equal to V, but this is the direction of the incident ray. So direction measured in a direction opposite, that's why V value negative. Similarly, so what is the value of BP? BP is what? Here B is there, here P is there. This is object. So distance of the which one? Object from the pole. That object distance is U. U value plus or minus? Minus. Why minus? So distance is measured from the pole in a direction opposite to incident ray. That's why BP value is minus U. And what about the value of FP? FP is nothing but distance between principal focus and the pole. So FP is the focal length. Distance should measured from the pole. So P to F value in the direction opposite to incident ray. That's why minus. Without knowing the sign convention, we cannot derive this derivation. Now, can I substitute the values of what is B dash P value? Minus V by minus U is equal to B dash P minus V plus minus into minus plus by minus F. So here minus minus cancel, V by U is equal to, can I multiply with the minus? What I will get? V minus F divided by F. You simplify this, you will get it. Finally, 1 by V plus 1 by U is equal to 1 by F. Okay, so what is, if you want you can check it. So that is the equation what I derived. That equation name is called as mirror equation. So mirror equation will give you the relation between object distance, image distance and focal length. But remember here I have derived the mirror equation by using which one? So by using concave mirror. You can derive so this one by using convex mirror also. What is the formula? I have derived the relation between object distance and image distance and focal length. So that can be also applicable, that can be also useful for convex mirror also. But the thing is, if you want to apply that rule, you need to apply the sign convention. That is the formula for any mirror. You can apply the formula for convex mirror or concave mirror, but with the sign convention. So sign convention compulsory. In problems you should not get confusion. If you are using a mirror equation either for convex or concave, formula same. But you need to apply the sign convention separately. Here though I applied the sign convention for concave mirror, when you are going with the convex mirror, so this formula once again you need to apply the sign convention. So this is regarding mirror equation. Derivation understood now? Similar triangle properties okay now? Okay? So this is the mirror equation. After completion of this, here we will define one more quantity that is called as linear magnification. One important definition here we need to define. So the definition is, what is linear magnification? What is linear magnification? This linear magnification represented by the symbol M. What is the definition of the linear magnification? Linear magnification is the ratio between the size of the image by the size of the object. The lateral size of the image by size of the object. This ratio is known as the linear magnification represented by the symbol M. So M is the ratio between the size of the image by the size of the object. Okay, so from the triangle, which one? So A dash, B dash, C and one more value I can write here. So what is the value here? I will write M value. So here actually if I call the size of the image, so can I call AB? So if AB is equal to H and A dash B dash value will be minus H. Why? Because so this AB was there above the principal axis and A dash B dash is there below the principal axis. So we know the sign convention, those heights which are measured above the principal axis are positive, those heights which are measured below the principal axis are negative. So which one? Then which is H divided by minus H dash. So H dash by H dash, H dash by H. So that means, so for a concave mirror which will form the real and inverted image, the magnification value negative. Whenever the magnification is negative, immediately you have to identify, so image is real and inverted. So M value minus H dash by H. In this diagram, so from the triangles, which one? ABP, similar triangles ABP and A dash B dash P. So these are also similar triangles. From these similar triangles, so what can I able to write is, so B dash A dash divided by B into A is equal to B dash P divided by B into P. Can you remember? So in the triangle ABP and A dash B dash P, both are similar triangles because of the same vertices, and right angle similar triangle. So B dash A dash by BA is equal to B dash P by BP. Okay, so what is the value of B dash A dash value? B dash A dash value or A dash B dash. So this is minus H. Can I write without sign convention? This is H dash by H. So what is the value of B dash P? B dash P value minus V by, this is minus H dash by H by minus U, BP value. So minus minus cancel. Finally what I got? H dash by H minus value is equal to V by U. Therefore, the magnification can be also defined as minus H dash by H is equal to V by U. If I want to return the magnification, one more definition, the magnification, the linear magnification of a spherical mirror can be also defined as the ratio between the size of the image by size of the object, or it is the ratio between the distance of the image by distance of the object. So directly I have not written, I showed the derivation. With the derivation only I have written that, so M value is equal to minus H dash by H is equal to V by U. But always remember, magnification negative means image is real and inverted. Magnification value positive means image is virtual. So a concave mirror will form a real image, real and inverted image. Clear, Dara? This is regarding mirror's equation. And this is about till now what I have discussed, that is for reflection. Yesterday we have seen light will exhibit several properties, like first property reflection, second property refraction, third property interference, fourth property diffraction, polarization, the next property is photoelectric effect. For explaining these properties, so we have four theories are there: Newton-Corpusculus theory, Huygens wave theory, Maxwell's electromagnetic wave theory and Planck's quantum theory. So in this chapter we are discussing the ray nature of light. Okay, so till now the first property is completed, then I am starting the second property. So first property of reflection will be there or will not be there a doubt, but second property no doubt, the complete ray optics based on the second property only. So from the second property, still clearly, still in detailedly, without any doubt, so we need to discuss each and every topic. The topic name is refraction. So what is refraction? First property reflection. Reflection is the property due to which what happened to the light ray will be bounced back into the same medium. So that is called as reflection. Actually before reflection one more property was there. Actually the basic property, first one is rectilinear property. So what is the meaning of rectilinear property? light always travels in a straight line path. So this property name is called as rectilinear property. Okay na? Light always travels in a straight line path. That property name is called as rectilinear property. So now reflection completed. So reflection understood now? In reflection we got a 1 mark question reflection definition, 2 marks question laws of reflection, 3 marks 2 derivation, 1 derivation F is equal to R by 2, and another derivation mirror equation, and 1 more 3 marks question is sign convention rule for the reflection. Now what is refraction? So let me consider one interface, one boundary. Let us suppose this boundary separating the medium into 2 parts. This is first medium, medium 1, and this is the second medium, so medium 2. There are 2 mediums are there. First medium is there, second medium is there. I have drawn one interface which separating the 2 medium. Okay, and I have drawn normal to the interface. This is a normal drawn to the interface. Then what I did, I made a light ray to incident on this interface. So let me call the light ray name is PQ. How light ray travels in a straight line path? So because of the property of rectilinear, so what we are expecting, light ray should travels in a straight line path. The path of the light ray will be straight line. If it is rectilinear, it travels in a straight line. So because of the refraction, so what happened, instead of going in a straight line, here I will draw still straight. This is the actual path the light ray should go. But because of the property of refraction, instead of going straight, so what happened to the light ray will bend slightly. This is the light ray will follow the path. PQ is the incident ray and QS is the refracted ray. So what is the meaning of refraction? Refraction is a phenomena. It is a phenomena. In this phenomena what happens? Whenever light is traveling from one medium to another medium of different refractive indexes. Here I should know what is the meaning of refractive index. The refractive index of the medium. Like in electricity we got one constant that is called as permittivity. In magnetism we got one constant that is permeability. Permittivity is the electric property of the medium. Permeability is the magnetic property of the medium. Like in optics also, the optical property of the medium is given by the refractive index. Once again I will discuss that. So we need to discuss this refractive index. Just I am telling, this refractive index can be represented by the symbol N or it can be represented by the symbol mu. What is refractive index? It is one optical property of the medium. Optical property of the medium. Optical property of the medium. Based on this refractive index only, we will classify the medium as rarer medium and the denser medium. So mediums are classified into rarer medium and denser medium. So actually what is the meaning of rarer medium? Whose optical density, generally the optical density will be measured by the refractive index N. So N value is less. Here mass density means what? Mass per unit volume. Similarly optical density will be there. That optical density will be measured by this refractive index only. Are you getting? We will write density with rho, but optical density with N. If the optical density value less, such a medium is called as rarer medium. What is that medium name? A rarer medium. So if the optical density is more, optical density that is nothing but represented by refractive index is more, that medium is called as denser medium. So one is of rarer medium, other is of denser medium. Always remember which medium refractive index is more, that medium is called as denser medium. Which medium refractive index is less, that medium called as rare. Can I call for example mu1, this is mu2. So mu1 is the refractive index of the first medium, mu2 is the refractive index of the second medium. For example, if mu2 greater than mu1, so which density more? Optical density, second medium. So that's why second medium denser or rarer or denser, and first medium will be rarer. Always remember. So whether medium, classification of medium based on the optical property of the medium or optical density, so that is only called as a refractive index. Whenever a refractive index of a medium is more, that medium is called as a denser medium. Whenever a refractive index is less, that medium is called as rarer medium. So whenever a light ray traveling from one medium to another medium of different optical density or different refractive indexes should not be same. So if the refractive index is same of the two mediums, then this refraction will not occur. Now let us see what is the definition for the refraction. So refraction, important definition for 2 marks. So define refraction, 1 mark question. And someone is asking frequently for the notes. So after refraction in the next class, so if possibility is there, so I will show this complete refraction with one PPT. So okay, then on that PPT all derivations and all whatever the definitions you want, so that everything will be there cleared, then you can make it one screenshot, so you can write down notes easily. So because last time what we have discussed, that notes from your which one, seniors, so there it is parallel coaching in the sense there we have discussed both subjective and objective at a time, but now discussing only for subjective. So completing the subjective part, so that notes as it is I cannot give you, so that is a problem getting. So that's why this problem can be solved. I will show you that PPT. So in that PPT it is clearly given the definitions, everything, so that time you can take a screenshot and you can copy into the notes. So just to concentrate on listening. What is the definition of refraction? So refraction is a phenomena. It is the phenomenon of bending of light. Basically it is nothing but bending of light when light traveling from one medium to another medium of different refractive indexes. Can I write? RI stands for refractive index. When light traveling from one medium to another medium, instead of going in a straight line path, what happened to the light? Will bend. This property of light is called as refraction. The refraction is a phenomenon of bending of light when light traveling from one medium to another medium of different refractive indexes. This last line is compulsory. If the two mediums are of same refractive index, then what happen? Light will never bend. In order to bend, so light should travel from one medium to another medium of different refractive indexes. Are you getting it? So this is the definition of refraction. Here I define the refraction and also I define the rarer medium. What is rarer medium? The medium refractive index is less. And what about the denser medium? The medium whose refractive index is more. And also I given the rough definition for the refractive index. The refractive index is the refractive index is the optical property of the medium. Clear, Dara? After this, what is the meaning of angle of incidence? What is angle of incidence? In reflection also we define what is angle of incidence. Now this is my interface, this is the normal, this is my incident ray and this is the reflected ray. What is angle of incidence? The angle made by incident ray with the normal. The angle made by which ray? incident ray with the normal is called as angle of incidence. Are you getting around? So angle of incidence can be represented either with I or theta. The angle made by which ray? Incident ray with the normal. Normal know that na? So this is a perpendicular. Perpendicular drawn to which one? Interface. Similarly, what is angle of incidence and angle of refraction? So what is angle of refraction? Angle of refraction nothing but this is my interface, this is the normal, this is the incident ray, this is the refracted ray. So angle made by which ray? Refracted ray with the normal is called as angle of refraction. So one is of angle of incidence and other is of angle of refraction. Definition understood or refraction? In this diagram, light ray traveling from which medium to which medium? Light ray traveling from optically rarer medium to denser medium. Whenever a light ray traveling from optically rarer to denser, light ray traveling, so light ray is bending towards the normal or away from the normal. So this is the actual path the light ray should travel, but the light ray path is changed. Okay now, the angle made by incident ray with the normal is called as angle of incidence. The angle made by the refracted ray with the normal is called as angle of refraction. Okay Nara, angle of incidence, angle of refraction. So one more is, what is angle of deviation? There also same. If reflection understood means same as that of reflection, here it is of refraction. What is angle of deviation? Angle of which one? Deviation. So angle of deviation nothing but there also. What is angle of deviation? In reflection, so this is the reflecting surface, mirror. This is the normal, incident ray, reflected ray. So reflection or the light ray will travel. The angle between the reflected ray and incident ray is called as angle of deviation. Here also the same. So actually what happened? If this reflection or this is the light ray travel path, the angle between the direction of the incident ray and reflected ray. So that angle is called as angle of deviation. Angle of which one? Deviation. So this delta value. Are you getting Aram? So this value will be equal to one angle of deviation. How can I calculate the angle of deviation? Angle of deviation delta is given by I minus R. I minus R. If you want to calculate from the geometry only, if I want to calculate from the total angle, so this total angle value equal to I. From this total angle, if I subtract R, I will get delta. So what is delta value? Angle of deviation. So is I minus R. But this delta value is I minus R when light traveling from optically rarer medium to denser medium. Optically which medium to which medium? Rarer to denser. Are you getting Ara? What is the rarer medium definition? Okay na? What is denser medium? Okay na? What is refractive index? What is angle of incidence? What is angle of refraction? And what is angle of deviation? But remember here, whenever light ray traveling from which medium to which medium? Optically rarer medium to optically denser medium, light ray will bend so away towards the normal. Whenever a light ray traveling from rarer to denser, angle of incidence is greater than R value. You can see the diagram. This is I, this is R. Which is greater? I value greater than R. But when light ray traveling from optically which medium to which medium? Rarer to denser, the angle of incidence value greater than angle of refraction. That time the angle of deviation given by I minus R. What is? Angle of deviation given by I minus R. But for suppose if the light ray traveling from optically this is denser and this is rarer. Whenever a light ray traveling from optically so denser medium to optically rarer medium, so what will happen? Here the light ray is there. Light ray traveling from optically denser to rarer. So this is the actual path followed by the light ray. Whenever it is traveling from optically denser to rarer, the light ray will bend away from the normal. So incident ray is PQ, refracted ray is QS. Why it will happen, I will discuss, but just to remember, whenever a light ray traveling from rarer to denser medium, it will bend towards the normal. Whenever a light ray traveling from denser to rarer, it will bend away from the normal. The reason is, so whenever a light ray traveling from generally, the velocity of light in rarer medium is more. then the denser medium. With increasing the optical density, so velocity of light decreases. Light travels fastly in rarer medium, slowly in denser medium. When light traveling from rarer to denser, because of the decreasing of velocity, it will bend towards the normal. When light traveling from denser to rarer, velocity increase, due to that reason, it will bend away from the normal. Here we got one conclusion that the bending is because of the change of velocity. Due to the change in velocity of light, the bending will occur. So whenever a light ray traveling from denser to rarer, so the angle made by incident ray with the normal is angle of incidence. The angle made by the refracted ray with the normal is angle of refraction. So whenever a light ray traveling from denser to rarer, so angle of reflection value greater than angle of incidence. Are you getting our angle of reflection value? This is equal to I. But now what happens? Sorry, not this angle. So this angle, this value equal to R. Angle made by the reflected ray with the normal. So that's why R value greater than I. When R value greater than I, so angle of deviation, the angle between the reflected ray and this angle. So delta value will become R minus I. So you had to remember the angle of deviation may be I minus R or R minus I. When I value greater than R, so I minus R. When R value greater than I, so R minus I. This is called as angle of deviation. Are you getting up? So just this class we have started introduction. So we will continue the remaining very interesting and important topic. So remaining will continue in the next class. Okay na? Thank you.